everyone, and welcome. Thank you all so much for joining us today for this live stream event. My name is Alexia, and I am the Program Manager of the Microsoft Reactor Toronto. I will be sharing session resources with you in the chat, but before we begin, I'd like to quickly review two items, our Code of Conduct and event guidelines. First, please take a moment to review our Code of Conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. The session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. I will be sharing the link in the chat for our on-demand content. And lastly, if you have not been on a live stream through YouTube before, please note that you must create an account on YouTube in order to have access and interact in the chat. You can set that up now. And if you're unable to use the chat but have questions, feel free to reach out to us through social media or on our website. Which brings us to today's session. I'm going to bring in our speaker here for today, José Luis. Hello, hello.
Hello, Alexia.
Welcome back to the Reactor.
Thank you so much.
Yeah, we're very excited for today's session on AI agents. So yeah, thank you again so much for being here. And
A pleasure. What else? Agents. Ooh.
Awesome. Yeah, we're excited for it. So without further ado, take it away.
Perfect. Thank you. So I'm sharing my screen. And first of all, yeah, you guessed that. AI is amazing. You're probably thinking Gen AI and all this incredible stuff about it, it's amazing. But what if I told you that with agentic AI, which is not the same as agents, right? You can do so much more and push your current models beyond what's even the future model will be able to achieve. Do you believe me? Probably not. And because it's quite a strong statement, right? But I would like to show you today a bit that this is true. We have some, yeah. So let's move on. The session today is about exploring AI agents with AutoGen .NET. I know a bit of Python, but mostly I do things in .NET. Those that know me, I am playing around a lot with semantic kernel and also AutoGen in .NET. So let's get back. I work at Swiss Life, a software engineer in the core tech team in developer experience, together with a fantastic group of colleagues. And one of my passions, which lately I don't do at work, is Gen AI. I would not call me an expert. It's such a very big word to use, but I can say I've recently finished my third course in LinkedIn Learning, which is about Gen AI. So I would say I know one or two things, but also if anybody approaches you and tells, hey, I'm an expert in Gen AI without specifying a concrete thing, run away. That's humanly impossible unless it's an AI. But I know one or two. So, yep. Already. So today we're going to dig in what can we do with AutoGen.NET. We are going to see a couple of patterns. We are going to implement them, or at least see how they are implemented. We have kind of a bit of 45 minutes, so I'll try to be on time. And today, yep, I'm going to show you that what I just told you is true. Aside that, on my course in LinkedIn, I'm a Microsoft MVP on AI and software development. I'm created the Global AI Zurich, which we had today at 1 p.m. Central European Time, one event about the news on Ignite, which is pretty cool. We were like 5 different MVPs, and we summarized what happened in 4 days in AI in just kind of 1 hour. So, and also I'm leading the .NET Zurich user group, and for those that are on that user group, I've been like super overwhelmed, but I plan an event already for January. I'm in the middle of it, so you will hear about me on that very soon, I hope. All right, let's move on. Today, as an agenda, we'll have an intro that I'm almost done. We will check what is agentic AI, what is AutoGen, what can we do in that on the base, and regarding also agentic workflows. But we will see about that in a moment. So to start quick, we have an agent. What you're seeing is a fun representation of an agent because AI doesn't need to be boring, right? So we can have this very funny little yellow boy which has ability to plan how to do task. It has a personality, which you can guess which one if you have been to the movies or you have kids and can use the tools. In this case, it's banana in the hand, but it can be any other thing, like, for example, using Microsoft Graph, using your API, or anything that you can code, it can use, basically. So, and it can have as well memory and other features, but let's keep it simple. An agent can have a persona, a personality. And of course, it defines in a very interesting way how it will react to a situation. If you give a task, in this case, if you have a blackout in Avenger City due to a problem in the power plant, you can guess which is the personality that is more fitting. If you ask Hulk, Hulk will smash darkness, which may not be a good thing in a power plant. If you do that, give that task to Thor personality, it will try to use its tool Mjolnir and try to use lightning on a power plant. But good luck with that. And if you give that to Tony Stark, probably it will speak forever, and at the end it will propose to make a party or use an arc reactor if that thing existed, or propose some more engineer approach solution to it, which would be probably a better option. So it really affects how an agent does the task, its personality. It's not just something fun to have. It's very important. I like to think of agentic AI as a collaboration, like an orchestra of agents. If you think of an agent as a musician and the tools it can use as the instruments, yep, it makes sense. It does. You give a task, you have kind of an orchestrator, which can be an agent that defines how to do the task, or they can decide that on impromptu. And you usually have a manager that is the orchestra director and tells everybody what to do and how, and they simply do it. And that's kind of a very nice approach to agentic AI. It can be a lot more complex, but yeah, we can put that there. So, what is the difference between normal usage of AI and agentic? Let me show this because this is very eye-opener. You have the usual workflow where you open ChatGPT, you go there and you ask, hey, write me a blog post about .NET Day for LinkedIn in one go, which probably you will not get. You start, you make a very nice prompt, you're maybe expert on prompt engineering or not, the LLM model will do the work, and at the end, you will get an output, right? That probably you have to revise, check, see, oh, this is incorrect. Hey, please, can you add this point? Oh, this point is incorrect. I don't want that. And you will have to dedicate here 2, 3, 4 or more times your work and your time to get it to where you want it to be. With agentic AI, with an agentic workflow, it is quite different, and it can be completely autonomous. So if you ask it again, write me a blog post about the .NET Day, which is an event I love here. I've been like collaborating with it like 3 years already. Last year I was even speaking on it about agentic AI. What else? And it's super cool. If you come here, I think it's usually about August, you should come to it. It's pretty cool. So coming back to the blog post, the agent, you want it to realize if it needs more information, it will write a starting draft, it will consider a revision and self-revise it. And also even you can review it for style and more things autonomously. So basically, we call it the creator critic workflow, which we have a lot of papers with it. And yes, this creates the first draft of your article or whatever you want to create, and then it will iterate. You will have another agent, which is the critic. It will criticize it and provide improvement feedback for the creator. And once it does not have more criticism to make and things, now it's perfect, it will say, I approve it. Or you can do that after a certain number of turns if you don't want to spend too much money on the tokens. But yeah, at the end, you will get a fully checked article, which is ready almost to publish. So saving you time here on these other iteration for reviewing. So I hope it makes sense. At the end, it's a time saver. Already. So I mentioned papers, at least I'll give you one or two. So we have the self-refine, which is a paper based on iterative refinement using the same LLM, not agents. But it shows that with some accuracy initial, it can go a bit higher, right? So it's simply using a prompt technique or simply doing another separate prompt to tell the LLM, oh, review that and criticize and refine my output, which it does not have that much improvement. But it depends. On some different actions, it has a lot of improvement, like dialogue response. Depends on the model. It can be even like 49%. Well, it depends. But this has a problem, which comes engraved in the same agent. If we want to wrap these, so it does not have focus. It's like we persons. You have one person which is specifically tasked and specialized in doing a translation or reviewing a document or reviewing code. That person will do better, and so will an AI agent. And that's the concept that we have behind on the next paper. More agents is all you need. I think half the papers in archive have all you need behind. But basically, it's about the scalability, making a very simple sampling strategy. Sampling is, I give the same task, in this case, on this paper, you give a mathematic task to n number of agents, and you get n number of answers. And finally, the agents vote which one is the best. And this will provide a huge improvement. Well, huge, about 20%. Oops, let me get that back. So we are in, for example, here 40 on Llama 213B, and it will, well, get close to 60, think more or less 60 or a bit before 60. So it's quite a lot with a very, very simple technique already. And then we have this drawing, this analysis. This is a test that was done by Andrew Ng. He is the author of Coursera, well, the CTO of Coursera. He created it, and now he has deeplearning.ai. He's quite a known person, and he was the head of AI at, I think, at Google some years ago. So he's quite a personality in the AI landscape. So he kind of knows what he's talking about. And he is these days talking everything about agents. Just looking Google, YouTube, or Bing, or ChatGPT, or Andy NG, and agents, and you will see. So what does it stand? It gets a lot better. So zero shot for the using zero shot at the moment for this human evil benchmark. The human evil is a coding benchmark, is almost 1 year and a half old, about coding capabilities of LLMs. And here is the GPT 3.5 zero shot. If we look at GPT-4, which is the next model, it gets to 67%, which is quite a big of improvement. It's a difference. But what if we apply agentic multi-agent techniques to GPT 3.5? It does not match GPT-4. It beats it by far. It gets to 95%. Of course, you will have several interactions, but at the end, you have several agents that are working together, collaborating, and that brings a model to the limit using what humans know to do best: human collaboration, communication. Of course, if we use the same for GPT-4, it gets better, but not that much. So the improvement between both models gets like a 2 or 3%. Wow. I think this is significant. I don't know what you think. I can only see the comments that you type. So if you want to comment, you want me to make a question, I'm happy to take the questions as you get them. So, yep, already. No comments so far. So that's the power of agentic AI. So I think it's worth to invest some time on it, right? From 48 to 95 and 67 to 97. So I think it's what squeezes the model and brings it to the limit in an incredible way, bringing what makes us human, collaboration, to the AI landscape. And it's not just me saying that. So we have Jensen Huang, we have Andrew Ng saying this. If you had to pick a technology trend to focus on and only one, it's AI agents. Of course, a lot of more people, I think I got twice Andrew Ng, but he's so relevant. And I really like how he thinks Bill Gates, McKinsey, and also more people say that. I could fill several pages with these strong statements of really truly experts on the matter. So, but so it's not just me. It's basically everybody telling you get into agents. So let's go. AutoGen. If that was a live audience, I would ask, who knows about AutoGen and what is it? Basically, it's a open source programming framework for agentic AI, an experimental one, and take it with a bit of salt. So AutoGen is there to experiment, to break things, to evolve very fast pace, to do experiments and have a lot of breaking changes. So my feedback to you, for learning, for having fun, it's good, but don't use it in production. For production, just go to semantic kernel. It's meant for that. And AutoGen is meant to create multi-agent conversations with different agents and to build applications with it. You have 3 different types of agents. Yeah, I know you're seeing 4 here, but one is the base type. So it's a conversible agent that can or cannot talk to a human. It depends on that. If we say never, it will be either a group user proxy agent or, sorry, an assistant agent or a group chat manager. And if we tell, oh, you will always talk with a human, you are creating the user proxy agent that you see down below. An assistant agent is simply an agent that will take an instruction, do whatever he can, and if he doesn't know how to proceed, and he has a user proxy agent, he will tell, hey, can you ask the user if he wants to do this or that? That's it. And the user proxy agent is your point of contact for you. It's kind of, you are having a AI team of agents, and your team lead is the user proxy agent, which you talk to. That as simple as that. And the group chat manager, we will see. It's the manager of the talk. So it's when somebody has finished doing what he has to do, he will ask the group manager, hey, what do we do next? And he will think, oh, now it's the turn of this agent to do whatever he's defined to do. All right. So initially, the conversation with an agent, it's the basic thing on a conversible agent is they will have a message. It will have as well with the message some context. Maybe you have a human in the loop, depends on the type of agent. And if not, this will be skip. And it will execute the LLM, execute code or tools, and then provide a reply. That's basically it, nothing more. So this is a very basic construct. That you can customize agents, so you can create different agents, and you can have a multi-agent conversations, kind of a hierarchical chat or joint chat, where there you will have a group chat manager. So it's kind of flexible. With that, I would say that this is changing. So, all right, Microsoft Reactor, some AutoGen for Net 2, nice. Then you have, when you have a human in the loop, you have a user proxy, which is who the user speaks with, and then the assistant agent that simply receives the input from the user proxy agent and does the work. In this case, it's an LLM configured to execute and write Python code. So you can tell it, plot a chart of Meta and Tesla stock price, change year to date, and this will be delivered to the assistant agent, and then it will simply broadcast the messages from it to us, like, oh, we don't have this package, and yeah, and there's some resolution in there, and finally you get what you want after some internal dialogue that gets externalized. So I think it's pretty interesting and also very, very similar to the process that you have when you work with ChatGPT. But for that, you will have to try that. The base chat is the base construct when you have something called a chat, and it's based on an input, the context. You have an initialization of that to prepare it to start a chat with its own history. So if you're familiar with a chat manager, you have a history of messages. One are the system that define the behavior, and other are the user, and then the agent are also in there, like our responses from the LLM, in this case, or the different LLMs. And you can have several kinds of implementation. You can have a two-agent chat. We will take a look at that in a moment. You can have a sequential chat, a group chat, and a nested chat, which brings it to the layer of composability, which is something we can achieve very quickly. And then at the end, with the history is delivered, and you can do a summarize, which usually is get the latest message. If it's an proof based, so the latest message will be the proof, and the previous one will be the proper response from the last agent. And or you can summarize the full conversation. It depends on what you want and what you have to do with the chat result already. The two-agent chat is simply the same, but it's an interaction with two agents. What we saw before, the maker and the checker, or if you want to define it, one is creating content and the other is reviewing or criticizing the content. Like one is writing code and the other is doing a code review. And at the end, after a few interactions, you get a very better output. So I think Eduardo Cucharro, which features it has that differs from semantic kernel? Would you please make the comparison? Yes, of course, Eduardo. That's a very good question. First is the stability of the platform. So I recommend that you use semantic kernel for anything that is company wide, and it is a lot safer to do that. And the other thing, at the moment, you have a bit more abilities in agent here for the composability that you can do. So you have something that we will take a look, which is the middleware pattern, which you can implement the nested chat. But you will have to wait like 2 or 3 slides for looking at that. But I really like this. But also, I would say that this is reaching semantic kernel in a very big way. So semantic kernel is developing. It has something that was announced like 8 weeks ago. It's called the process framework. I don't know. Are you aware of that, Eduardo, of the process framework? Then I would recommend that you either follow me. I got like 2 blog posts on the process framework, and there are like a couple of entries in the semantic kernel blog, which are pretty good. I'm also collaborating with it to try to make more simple. So a couple of the examples are mine, and I'm trying to also implement the visualization. It's already on a PR, so you can check the PRs with me. I can quickly show it later. But I recommend that you focus on semantic kernel for production. And also there is a news right before Ignite that AutoGen, the next version 0.4, is going to use the core of semantic kernel. So for once in a lifetime, I'm joking, the two teams are aligned, which is incredibly good. So they are collaborating in that. I understand that the process framework will be the core of agents in .NET and Python, and I don't know Java, but at the moment AutoGen is mostly Python, and there has a light implementation in .NET, which is brilliant. This is what I'm going to show. So I do recommend that you use semantic kernel and keep an eye on the process framework. I hope this responds to you already. So to understand a bit better the two-agent chat, you have a human that delivers a task to the writer, which is one of the agents. And then the writer tells the critic, hey, here is what I have written. criticize it. And then you get the feedback. And this goes on a number of times. And once this is approved and says, yes, now it's perfect, we have this 95% quality or 97 that we saw, and then it goes to the summarizer. The summarizer summarizes and gets the last message or the approve text to the human, and the human is happy because he doesn't have to check that. Good. So for this, we are going to use AutoGen for .NET, which I think it's quite interesting. This happened in the day of September 29, a pull request from somebody named Little Cloud, which is Xiaoyun Sang, sorry. And I've been in touch with him because I prepared this a couple of talks, and it was cool. He pinged me, hey, what are you using for demos? "Oh, I'm using that based on your demo." And then the next moment, like in less than 1 hour, he did a pull request to my code base, which I say, okay, nice. That's a good interaction with the product team. Not good, incredible. So it's quite motivating. The people, they're super, super nice. So thanks, Jojon. Already, time for a demo. So what I show you, I'm going to show it in code. So I have Hello, hello. Can you hear me? Perfect. I'm back. Whew. Don't know what happened. My computer froze. I was kicked out. So luckily, I managed to rejoin. So where was I? There is this paper, which is persuasiveness of large language models. So one thing that they acquire about April last year is TOM, theory of mind, which means that LLMs, large language models, are able to understand how we think and act and what triggers us. So yeah, they are psychologists. So I say, let's use that in a fun way. So I did this TOM argument cheat sheet where it's very simple. So the first thing is I use the AutoGen package. I use AutoGen OpenAI and have to make use of a couple of more. The code is on my GitHub available. So it's JOSLAT. I will share the link in a moment with Lixia, so she can share it with you. But in short, it's fairly very simple. So this is based in an example of Little Cloud, Xiaoyun Zhang. As I mentioned before, I get the OpenAI key from my environment variable, so that's a good practice. Don't put keys in your code, set the OpenAI model. I'm using GPT for O mini, enough for this, and then I create an OpenAI client, and then simply I create a connector and do some fancy printing thing, and I create a bit of context. So it's a company based on Zurich. I create a profile for a worker. I create a profile for a boss. I create a conference summary, which is from this August event that happens in a city, in one of the biggest cinemas of the city, Tornet Day, Switzerland. Pretty cool event. If you come around, just come and check it. And then you create an agent, an OpenAI chat agent. So you give it the OpenAI client, you give it a name, the model it has to use, and then a system message, which is nothing more than instructions. How I do that? I use basic prompt engineering. I use format to define the context in different sections, which an LLM will be happy if you give that to it. And I give the task. And then you simply specify how you want this with some creativity. And that also you will take feedback from the critic team lead. That's it. And then you create the critic, the agent. So you create another OpenAI chat agent, your critic team lead, expert in understanding team dynamics and leadership perspectives. And then you will provide suggestions to improve the argumentary. So what the maker will make is an argument of how to sell the conference to your team lead, which you have defined. We are using here theory of mind. So it's a human AI personalized, which it has chances to, well, do a lot more than just changing the view, but changing it completely. So this is like a turnaround of 150%. And it's pretty cool. And this has only to provide constructive feedback, summarize, and if there is no more feedback, you respond with terminate. That's it, right? Finally, I create a chat history telling it the first instructions. I will use some colors for the different elements. And then I start for each. Meanwhile, the message is not finished. Sorry, it has not reached the terminate, which I check. And then I will take the last message before the terminate. And then simply print a different color based on who is speaking. As simple as that. And there is not too much more. So what happens if we execute that? And the gods of the demos makes it to be able to run. I'm waiting for this system. Yeah. All right. So we have the first draft, how to start the conversation, some main points, two arguments. And then I tell it, okay, give me the possible questions from John and the best possible responses, which is quite cool. I mean, if you have to present at some place, this will, adapting that, of course, it will save you a huge amount of time. Just try it, and you will be surprised how cool it is. And then you will have some iterations. This is the second round based on the feedback from the critic. Now it's round 3 and it's terminated. So it's for it perfect. Whoa, that's it. So how do you justify the cost of attending, for example, and this is the best question, the conference ticket is a modest investment compared to the potential return on investment. Knowledge gain can lead to more efficient coding practices and innovative solutions, saving us time and money in the long run. I hope you get the idea of what we are doing here. We are convincing a certain individual on something that we want done. Of course, it has to make sense. You have to have arguments, right? So let's move on. Agentic workflows. For this, one of the formats and structures I love is sequential chat. It's quite interesting. So you have what you have seen now, these 2-agent chat, but you have it nested. And if you want the updated solution or outcome, you can add it. And it's kind of, we call it the carryover. And it gets into as another part of the context. And this is chain, or it can be chain if you want. That's pretty useful. Another one is the group chat, where you have this element, this agent, the group chat manager, which is unique role is to tell you go next, you go next, you will speak next. But if you think a bit ahead, is kind of a bottleneck, it has a problem. Also, you can do something less advanced. You can do round robin, everybody speaks once, you can do it random, or you can ask the human, which is even a bigger bottleneck. Usually it's automatic, LLM decides, the group chat manager decides. To understand it better, let's put it in action. You have a human, goes to the chat manager with a task, it will give it to the writer, and the writer will give it, will deliver it back to the chat manager. The chat manager says, oh, it's ready for review. I will send it to the style reviewer. And once it's back, we'll say, now the legal reviewer, and then the style reviewer, and then the CEO reviewer. You see the problem there? I do. It's a bottleneck. The chat manager is a bottleneck. And every single interaction you do, the chat manager will have to go in there and the chat history will grow. And the chat history goes to usually to every single agent, which is more tokens, yes. But well, and finally to the human. Another thing that I like is the nested chat. This is as simple as in any agent, you can grab an agent workflow. So instead of one agent, you can put a 2-agent chat, you can put a sequential chat, you can do anything, or a group chat. So it can really grow as you want, and you have this composability. I really like that. It's pretty powerful. For doing this, we will have yet another demo. We are still 40 minutes. We are on time. Let me close this one. I will comment this one. I'm going to check the multi-critic execute, and you will like that because it's, if you like optimization. So here are some, this is based on one demo that I changed quite a bit. And you do the same that we did before. If my tongue wants to obey me, you get the OpenAI key. You can do that also with Azure OpenAI, and you get the model, you get the client, and then you get the conference description, which is simply assigning some text of the conference to string. You get a task, which you will use. Write me a concise but engaging 400-word article for the .NET Day Switzerland for 2024, or maybe for 2025. Should cover this and that, so you try to be concise and very clear and be catchy. And then you create several agents, not just one, not just two. You create the writer. You write engaging, concise articles, and that's his unique task. He has focus. Then you write the critic. And your work is only to ensure that everything is good, and you will provide feedback to it. But for the feedback, you will rely on your team of expert critics that we will create now. So you will have a SEO reviewer, you have a style, you have a fact checker, etc. So let's see how this is done. So you create first the agent, the SEO reviewer. So it's only to optimize content for search engines. You have the legal reviewer. So it will check that everything is compliant. You know that here in Europe, we love regulation, we love compliance, and something called GDPR. And yeah, that's getting very exciting, but also very necessary, also to protect your personal identifiable information. And you have ethics reviewer, so we don't want to do anything or say anything that is wrong in a public event. So, and then you have a fact checker because you like things grounded, because LLMs hallucinate. And this is one of the best ways to eliminate that. And I will show you exactly where it does that, because this even, it has a whole amount of information. And even I tell him, be clear, use the provided facts, it will hallucinate. It always hallucinates. But this, with the laser focus, check that all the content mentioned is found only on the context provided. It does the magic. And it works fantastically well based on this. Only on this source, I tell, use this. And then finally, I have the style checker. Yes, a lot of agents. And finally, I got a meta reviewer. Its only task is get all the feedbacks of all the specialists and condense them together to provide that to the writer. So for that, I create what I call a middleware. So this is kind of the nested chat way in .NET, but it's super powerful. And then I give it like, I think 1, 2, 3, 4, 5, 6, 7, which is a decent number now. Yeah, then I register the middleware, and just is to visualize the output. And then I simply send asynchronously to it, and we'll get the outcome of it, and get the last element of the conversation. But let's take a look at, this is not that important, it's a string to the middleware. So I implement only the I middleware. I define all the agents which are in the constructor. I assign them. They come already created. If you remember, we created them at the top. And then I simply invoke them. So I go and execute all the different elements. So I get the last message here, and then review. Yeah, I introduce here the review the different content, and I not, yeah, for one, the critic sends the message to the SEO, then to the legal, to the ethics, the fact checker, style checker. And then once I got all of them, note that here in this code, I'm awaiting everything, but I could simply assign them to task and do a wait all. So I could do what we know as a fan out and fan in, which will make that all this happens in parallel. And then I simply concatenate the feedback or the reviews provided by all the different agents. And then I use the meta agent to aggregate the feedback in a concise manner, easy to understand for the agent. And that's what I return. As simple as that. So I get it here. I'm going to save. I'm going to execute it. And if the gods of the demos. So I'm stopping the workflow. So line up. I could very quickly see things which are not good. So should be April 12th. The last edition happened in August. And that's on the context. So it's something that it hallucinated already. And on the first feedback of not the CEO, the fact checker, yes. First, date of the event. Wow. First incorrection. Source should be August 27, 24. Location, yeah. Should be specified, should be clear. Speakers, so it added some speakers that were from other years because they are in its memory, and also topics cover and the call to action, so it corrects it. And it goes on. It provides the summarization of the feedback, delivers that to the writer, and the writer writes it again, taking the feedback and listening to it. And yep. And now we have it, the article done. So how cool is that? We deliver work to a set of agents. This could be for writing an article, for checking that, could be for coding. Also recently, I don't know if you were attending Ignite, but one of the nice features that we have is that behind a Copilot, we can attach agents that can have a laser focus like we did here, which works exceptionally well. So that's it. That's the two examples I wanted to show you today. I think they are cool and show the power of what we did. And what we did or we can do is this. So we, from a human perspective, can deliver the task to the critic. The critic can send them one after another or in parallel, and then they can come back also in parallel. And then everything happens a lot faster already. So as a recap and takeaway, we have seen agents, agentic AI. Why is it powerful? What benefits does it bring? Which I think it's kind of amazing. And the response gets improved a lot. So the alignment that you usually have to do when you're talking with a ChatGPT or a single model that responds to you, which can have an agent behind or not, like GPT o1, for example, it's a lot better if you can streamline that with a set of different laser focus agents. Of course, you have to do that for a task. So you have to be mindful of where you're using that. And agents are becoming more. The reason that there were like 30 or 40 talks in Ignite alone that were focused in agents. And AI is getting better. I mean, we got the 3.5, then 4, now 4.0, now we got the o1. And what is coming next is, well, I cannot even imagine. It's getting crazy. And we are not talking about 7 or 8 or 9 agents, which is the maximum I show you today, but we're talking about hundreds, thousands that can scale in Azure. So you have to change your mindset. Our software now reasons and acts, right, and collaborates together. So it's getting interesting. So my call to action for you is start learning now. Now it's still, you have time. So get to it because the future is going to be, wow, impressive. Agentic AI is about to explode. Microsoft is working hard. They are collaborating together in these two frameworks, semantic kernel and AutoGen. And there was just released in Azure these Azure AI agents, which is pretty spectacular what you can do, and you can deploy them to the cloud and work standalone, can integrate with, I think it's logic actions, and it's pretty cool. There will be an increase in agent capabilities and their orchestration pathways, so it's going to be super, super cool. Again, it's been an absolute pleasure to speak to you. I have to have you inspire a teeny bit into embracing these fascinating topics, which is agentic AI, whether with its AutoGen, with its semantic kernel, or however in Azure, it doesn't matter. It's incredible. I hope this presentation has resonated with you, triggered some ideas, and make you think. Thank you. And this said, if you want to follow me, you have here some links, linkedin.in.joslt. My Twitter is, well, joslt, and the same with GitHub. Here is where I have the code that I show you today. So it's already up there. This aside, I help collaborate and co-lead two user groups, which is the .NET Zurich user group and the Global AI Zurich. You can take a screenshot also, or just go to JUSLT in GitHub, where this presentation is also there in PDF. So that's it. And that's it. I will take any questions on the, I think, 8 minutes we have left.
Thank you. Sorry. Thank you so much for this session. Yeah, it was so great to have you again at the reactor and for this insights and knowledge. We'll give it another minute or so for the audience to see if they have any questions. In the meantime, I know you said learn now is one of the key highlights here. So sharing some additional resources to learn more about AI here on the screen. You can scan the QR code. And for our audience, if you have, well, we are leaving some time for questions, but if you have one more minute to submit some of your feedback, what you enjoy about our sessions, what you enjoy less, or what you'd like to see more, feel free to scan this QR code on the screen or submit a survey at aka.ms/reactor/survey. The event code is 24218. We always appreciate feedback, so feel free to complete it. And yeah, it looks like we do not have any more questions. Everything else was pretty clear. Thank you again so much, Jose Luis, for being here with us today. And
Sure. Thank you.
look forward to the next one.
Thank you so much, Alexia.
Okay, thanks everyone.